Ratios. If you ask me how important this topic is, I would say any competitive exam, you will be having hardly one direct question, or sometimes it can be zero as well. But well, still I say this is a very important topic because in every question paper of quantitative aptitude, you will see at least 3 questions which involves ratios in it. Rather than being the direct questions, ratios is always part of some other topic. Like it can mean ages, percentages, partnership, mixtures and allegations. Mainly if you are preparing for banking exams, data interpretation. There won't be a single data interpretation question without using the ratios. So in this video, we'll be discussing in detail about ratios. Hi, I'm Abhilash Varma. Welcome to Learn Online. Now, let us understand what is the meaning of the ratio and why do we want it. Suppose if I talk about ratio of boys to the girls in the class as 15:20. Now if I take out the ratio, we will get 5 3s 5 4, 3:4. What is the meaning of this? If there are 3 boys, then there will be 4 girls in the class. Suppose if there are 4 boys, or let's say if I take 6 boys, then there will be 8 girls. If I take 9 boys, then there will be 12 girls and so on. So what are we doing with this? We are actually comparing the number of boys with the number of girls in the class. So in short, ratio is a comparison tool. Now, what are we using to compare? We are using numbers. So what is ratio? Ratio is a numerical comparison. Now again, what are we comparing here? Boys and girls. Can I compare anything? Can I compare water and sand like 3:4? It means 3 liters of water to the 4 kgs of sand. Does that make sense? No. Why? The units are not same here. Water is in kg, whereas water is in liter, whereas sand is in kg. We cannot compare these two. So what do we compare? We compare only the similar quantities, which should have the same units, or they should not have units at all. Like in this case, I can compare water and milk. I can compare sand and sugar. I can compare boys and girls because there are no units, because this is just a measurement, right? So what is ratio in simple terms? It is a numerical comparison between 2 similar quantities. Now you understood what is the meaning of the ratio. Now let us understand the mechanism of the ratio. Now when I took number 15:20, we got the ratio as 3:4, right? Now, what did we do to get this ratio? We divided with a common term between both the numbers, that is 5, right? If you write 15 as 3 into 5, and you can write this 20 as 4 into 5. Well, there is a common term between them, that is 5. So if we divide both the numbers with a common term, we will get the remaining part, that is ratio. Now if you see, this common part in both the numbers is 5, which is actually HCF of 15 and 20. It means if you want HCF ratio of any 2 numbers, divide both the 2 numbers with their HCF, right? Suppose if I take some other example like 42 and 54. Now what can you see here? I have to divide this number with the HCF of both the numbers. It can be 6. If I divide with this 6, I'll get 6 into 7, and this is 6 into 9, and 7:9 is the ratio. If you see, there won't be any other common term between them except 1, because these two become co-prime numbers. Recall, what are co-prime numbers? Co-prime numbers are those which doesn't have any common factors between them except 1. If you see, 7 and 9 are co-primes here. Even 3 and 4 are also co-prime numbers. So let me repeat everything one more time. So if you want the ratio of any 2 numbers, divide both the numbers with their HCF. In this case it is 5, in this case it is 6. Now the leftover part is the actual ratio, but make sure the numbers in the ratio are co-prime with each other. Only then you can call it a complete ratio. Now well, you understood that to calculate the ratio from the given numbers, you have to divide with the HCF. What if you want to go back to the original numbers? You just multiply with the ratio. I mean HCF. If you see in this case, 7:9 is the ratio. We know that HCF is 6. 2. If you want original numbers back, we'll multiply both the numbers with 6. 7, 6, 42. 9, 6, 54. That is the original number. Even in this case, HCF was 5. We'll multiply with 5 here, multiply with 5 here. This should give us our original numbers 15 and 20. So to obtain the ratio from two given numbers, divide the numbers with the HCF. Now to obtain the original numbers from the ratio, multiply with the HCF. Let us work a little more on this. Let's say in a class there are totally 180 students. The ratio of the boys to the girls is, let us say, I can take 4:5. Now find the number of boys and number of girls. Well, this is actually not the original numbers, but this is the ratio 4:5. Now we already have learned that we get the ratio only after dividing the original numbers with the HCF. In this case, original numbers of number of boys and number of girls. We don't know what they are. Now they are divided with the HCF. That's why we got the ratio 4:5. Now using this data, we have to obtain the actual number of boys and actual number of girls. Well, we know that if you want to obtain the original number, you have to multiply with the HCF. Do we know what is the HCF? No. Let us consider it as X. X is the HCF of original number of boys and girls. Now the actual boys will be 4 into X, 4X. Actual girls will be 5 into X, 5X. Right? Now if you add both of them, this should represent the total number of students in the class, that is 180. So this must be equal to 180. So 9X is 180, then X is equals to 20. What is X here? X is the HCF of both the actual number of boys and actual number of girls. So now if you want boys, we know that boys are totally 4X. 4 into 20 is 80. And number of girls, 5X. 5 into 20 is 100. 80 plus 100 will get actually 180. So this is how we calculate the number of boys and number of girls when the total students are given and the ratio is given. Well, there is another way of solving this. I even told you the meaning of the ratio in another way as well. When I say the ratio of the boys and girls is 4:5, it means if there are 4 boys in a class, then there will be 5 girls in a class. It means out of every 9 students, 4 are boys and 5 are girls. Well, if you want to directly calculate boys, we know that out of every 9 students, 4 are boys. So boys are 4 out of total 9 of the actual number of students, 180. If you solve this, 9 ones are 9 20s, 4 into 20 is 80, that is the number of boys. Likewise, if you want to calculate girls, now girls, again in this case, there are 4 girls out of every 9 students. So 4 out of 5. 5 out of 9 are girls. So of the total 180, again 9 into 1, 9 into 20, 5 into 20, 100 are girls. So using either of the ways, you can calculate the number of boys and number of girls, it in this case or in this case. Well, you might be thinking this is the easier way of calculating, this is slightly lengthier, but in certain cases you must be knowing even this method. Well, there is not even you cannot use only this method or this method for each and every problem. So certain problems demand this method and certain problems demand this method. That you will be seeing when we start solving the problems. So this is about the entire mechanism of the ratio. Now we shall see what all the different terminology that we come across ratios, and apart from that, few examples. Terminology. If A is to B is a ratio, it can also be written as A divided by B, where A is nothing but antecedent of the ratio and B is nothing but consequent of the ratio. Now other types of the ratios are, suppose if A is to B is a ratio, then A square is to B square is called duplicate ratio of A is to B. We call it duplicate ratio of A is to B. Likewise, if I take A cube is to B cube and root A is to root B and cube root of A is to cube root of B. Now, if A is to B is a ratio, A square is to B square is nothing but duplicate ratio. Likewise, A cube is to B cube is called as triplicate ratio of A is to B. I'm sorry, this is a ratio. Again, root A is to root B is nothing but subduplicate ratio of A is to B. Again, root A is to root B is called, you must be knowing by now, subtriplicate ratio of A is to B. Now, this is the various different terminology that we come across when we are dealing with the problems on ratios. Now, apart from this, suppose if I take something like this, let's say if I take A is to B, B is to C and C is to D, I'll take different values for this example. Like if I say 3 is to 5 and I can take 6 is to, let us say, 11, or another example, let me take 15 is to 22. Now, if these are the three different ratios, I can ask you what is the compound ratio of all the individual ratios. Now, what is compound ratio? Compound ratio is nothing but just the product of all these ratios. That is A by B into B by C into C by D. Now, we know our A by B is 3 by 5 into B by C is 6 by 11 into C by D is 15 by 22. Now, if we cancel these terms, we'll get 5 1s, 5 3s, 2 11s, 2 3s. Can we cancel anything further? No. What do we get? 3 3s 9, 9 3s 27 divided by 11 into 11, 121. So this 27 by 121 is nothing but compound ratio of all the three individual ratios. So in simple terms, what do you mean by compound ratio? Compound ratio is nothing but just the product of all the given ratios. Suppose if I have a very simple example like A is to B is 2 is to 3, B is to C is 3 is to 4. Now if I ask you to calculate what is A is to B is to C, well, this is very direct one. We know that A is to B is 2 is to 3. It means when A value is 2, B value is 3. Now with this ratio we can tell when B value is 3, C value is 4. So here B value is 3 means the C value will be 4 only. Directly 2 is to 3 is to 4. Very simple, right? Now what happens if I give you something like this? I'll give you A is to B as 2 is to 3 and B is to C as 4 is to 5. Now I'll ask you, what is A is to B is to C? Now, carefully here. If you want to calculate A is to B is to 3, if I write 2 is to 3 here, A value will be 2 when B value is 3. But C value is 5 when B value is 4. Well, the values for both B in both the ratios are different. What we have to do? You have to make them equal. How? Let me show you that. Now, to make it equal, in this case, we just multiply this ratio with this B value, that is 4, and the second ratio with value of B in the first ratio, that is 3. So if you do that, we will get A is to B as 4 into 2, 8. In this case, 4 into 3, 12. Now we got to know B value as 12. Now if you observe here also, 4 into 3 is 12, that is B value. It will be same. 12 is to 15 we have. So here B value is 12, here also B value is 12. We made them equal. Then C value will be directly 15. So this is how we calculate A is to B is to C. Now what happens if it is something like this? Check this out. A is to B and B is to C and C is to D. I'll give you three ratios now. So let me take this as 2 is to 3 and this as 4 is to 5 and let me take this as 6 is to 7. So in the first step, we calculate A is to B is to C. Now what do we need to calculate? A is to B is to C is to D. Well, we have already calculated A is to B is to C, because this is the same example here, but I just took the one extra ratio, C is to D. Now we know that A is to B is to C from our problem is 8 is to 12 is to 15. Agree? Now we use C is to D to calculate A is to B is to C is to D. That is 6 is to 7. Now if you write A is to B is to C is to D, what do? Multiply this side with this C value, that is 6, and this ratio with this C value, that is 15. Now what is happening here? If I multiply everything, I'll get A value 8 into 6 is 48. Now B value 12 into 6 is 72. C value 15 into 6 is 90. What is C value in this? If you see this, 15 into 6 is 90, because the common variable between both the ratios is C. Now our agenda is to make them equal. Here also 15 into 6 90, 6 into 15 is 90, so no issues. So D value 7 into 15, that is 105. Well, this looks like a final answer, but not. Why? If you observe, 3 is common in all these cases. So what do? Divide all the numbers with the 3. So 3 into 16 is 48, 3 into 24 is 72, 3 into 30 is 90, 3 into 35 is 105, and this is our final answer. Well, you might be having a doubt here. Why we are doing this extra step? In the previous cases, we didn't get it. So should we always have to check whether is there any common term between them? Well, you need not to if you know the simple trick in this. Let me tell you that as well. The same example I gave you. A is to B as 2 is to 3, B is to C as 4 is to 5, and C is to D as 6 is to 7. Well, we have already calculated in the beginning A is to B is to C, which we got it as 8 is to 12 is to 15. Now we have C is to D, that is 6 is to 7. Now what we are doing actually, we need to equate the values of the common variable in both the ratios, that is C value. That's why we multiplied this ratio with 6 and this ratio with 15. Instead of that, what I'll do is, here I'll multiply with a 2, here I'll multiply with 3. Why, I'll tell you later. Now look at the answer. A is to B is to C is to D. 2 into 8 is 16. 2 into 12 is 24. 15 into 2 is 30. Here also C value 6 into 3 is, this we have to multiply with 5, not 3. 6 into 5 is 30. Here also 15 into 2 is 30. And finally D value 7 into 5, 35. Now if you see, exactly the same answer. But why we got it directly? Simple. Rather than multiplying this ratio with this C value and this ratio with this C value, calculate the LCM of both of them and equate the value of C in both the ratios to their LCM. Now if you see, LCM of 15 and 6 is 30. To convert this 15 to 30, I just have to multiply with 2. In this case, 6 is there, I have to convert it into 30. So to convert 6 into 30, I have to multiply with 5. Well, I didn't apply this here. Why did we get the same answer? Now if you see, knowingly or unknowingly, we did the same thing here. I multiplied this ratio with this 4 and this ratio with this 3. Now what is the LCM of 3 and 4? 12. Now indirectly, we directly getting the 12 here. Why did we get that? If you see, 3 and 4 are co-prime numbers. Now during the number system, I clearly told you, when the given numbers are co-prime numbers, their product itself is the LCM. So when we took just 3 into 4 or 4 into 3, we are taking their product. Because they are co-prime numbers, we are directly getting the LCM. That is, but in this case, in this example, that is not the case. 15 and 6, 15 into 6 is 90, which is not their LCM. 15 and 6 LCM is 30. Now these two are not co-prime numbers. Like if they are co-prime numbers, the product should have given the LCM, but they are not co-prime numbers. Now always remember, when there are two ratios, make sure you always equate the value of the common variable in both the ratios. So the values has to be same. So that's when you can calculate the final ratio. To watch more free videos, download our LOL application from Play Stores. If you are benefited by these videos, please like and share our videos, and also do not forget to subscribe to our YouTube channel so that you don't miss any of our new videos that we upload regularly. If you have any queries or suggestions, please drop them in the comment section below. Also, if you want to reach out to me or any of my team members, you can always do that through any of the social media platforms, and the links of which are already provided in the description below.